So here we have a refrigeration cycle from a window unit. What we've done is take this window unit apart, we've separated it out. We're going to start with our compressor. Our compressor sucks in a low pressure, low temperature superheated vapor, pumps out a high pressure, high temperature superheated vapor. It is a vapor pump. It moves the refrigerant. This particular compressor is called a rotary style. Then we have our discharge line, also called a hot gas line, the shortest line in the system. This refrigerant is a high temperature, high pressure superheated vapor. From there we go into our condensing coil, and the very first little section of this condensing coil is going to de-superheat. It's all sensible, very little BTUs released, but big number change. The rest of this condensing coil is going to be condensing. That's going to be latent heat, changing state from a vapor to a liquid. As it changes state from a vapor to a liquid, it's rejecting massive amounts of BTUs of heat out of the refrigerant. But it's going to be the same temperature because it's latent heat. All that saturation. Below saturation, we now subcool it. We take even more heat out, but that heat is sensible. So now we leave the condenser as a subcooled liquid in our liquid line. The liquid line is a warm to the touch, high pressure, warm subcooled liquid. In this case is a sight glass where you can see the refrigerant flowing. Our liquid line filter dryer that's pointing towards our metering device. We continue with our liquid line, and here we have our metering device is quite special. This is a capillary tube metering device. It's also known as a fixed orifice style metering device. It is an expansion device. It is a metering device. It restricts it from a high pressure liquid to a low pressure saturated mixture, approximately 75% liquid, 25% vapor. The refrigerant through most of this evaporator coil is boiling, changing state from a liquid to vapor, absorbing a massive amount of heat, absorbing BTUs. In other words, absorbing heat away from the air. It's cooling the air off. The heat goes to the refrigerant to make the refrigerant boil. The refrigerant boiling is absorbing the heat. Now after we boil it all from a liquid to a vapor, the very last little bit of this coil superheats above saturation, but it's still low temperature. So this line is our suction line, also known as our gas line. If we touch this line, it's going to be cool to the touch. This line is going to be a low temperature, low pressure, superheated vapor. According to you and your feelings, it's going to be low temperature. According to the refrigerant in science, it's superheated. It is a vapor form. So that vapor is going to go all the way back to a compressor. And we have an accessory here. This particular accessory is called a suction line accumulator, and this protects the compressor from any potential liquids. They always go hand in hand with this style compressor. But it is our refrigeration cycle. It just refrigerant recycles over and over and over again. Refrigeration.